Let's do this. Here we go. Last constructions of the year. 4 today. And 2 of them, half of them, that I'm going to show you aren't even new. It's a construction we've already done this year, just applied to a circle. First one we're going to do, construct a tangent line. We all remember what a tangent was, right? Intersect the circle in exactly one spot. And this, there's a reason why you have your compass out here. I'm not going to, just let me line up my straight edge and yeah, that looks good. It hits once. Nope, we're going to do it with our compass. And to do it, we're going to use a theorem already from this unit. Draw a radius in for me to point P. Draw a radius in. From point P to the center. And what's this theorem going to have you think about? Well, when the tangent is finally complete, what am I going to know about those two? They're going to be perpendicular. They're going to form a right angle. So all I'm asking you here to do a perpendicular line going through P. We're going to need a little more room. Get back your straight edge. Extend the radius a little longer. We're going to need some more room to work here. So here's what I'm asking. Give me a line that's perpendicular to your radius, but going through P. We've done this already. We just got to remember here. Basically, here's what I'm asking. You got a point that's on the line. Give me a perpendicular line through it. Anybody remember some of the steps? Where should I put my compass? Point P, darn right. Let's go. Put it on point P. And then what are you trying to do here? Ellie, make an arc that does what, though? There you go. So move your compass around. Give me an arc coming from point P that intersects your radius twice. So basically, it's going to look like a smile or a frown, right? So you should have 2 points of intersection on that radius. I always recommend, it's not required, but I always recommend when I do this construction, after that first arc gets made, I always open up my compass a little wider so my point of intersection doesn't land on point P and I have nowhere to line up my straight edge. So open up your compass a little wider. Now I go to each point of intersection and I can do this above or below the radius. I'm going to make 2 arcs that intersect each other with the same opening of your compass. So I go to one point of intersection, make an arc above or below. Go to the second point of intersection, make another arc so those two intersect each other. And then I take my straight edge and I make my tangent line. Line it up, point P and the point of intersection. So nothing new. This was not a new construction. I just applied it to a circle. Questions? How to make a tangent line. All I got to do is make a perpendicular line through the point. Okay, we're all good? All right. Let's start doing shapes now. I need a square inscribed. Well, let's. Can we just review that term inscribed again? Because I can do this. That's a square inside. If it's inscribed, though, what do we know? Vertices have to touch the circle. All right. So let me just do let me do that. And we could talk. While I'm trying to fit this in here, properties of a square you're aware of? Okay, let's start right there. All sides congruent. Okay, these are sides of a square, but they're also what in my circle? Chords, aren't they? Okay, if the chords are going to be equal, then what else has to be equal? If the chords are equal, that means? So that's the theorem we're going to use to do this construction, that congruent chords, congruent arcs, I want to start with that. If I have congruent arcs, that means I have congruent chords. And how many congruent chords do I need again? 4, so that means I need 4 congruent arcs. Maybe you guys can help me with that. How can I make circle T, cut that up into 4 congruent arcs without using my, oh, that looks like 4. 4 congruent arcs I need to cut this circle up into. Well, maybe I was asking too much. Let's lower the expectation. Can you at least give me 2? 2 congruent arcs? How? Just grab your straight edge right now. Throw a diameter in there. I don't care what it looks like. Throw a diameter in there. All right, we got 2. How do I make it into 4 now? And the answer is not, oh, let's throw another diameter in. No, that doesn't guarantee that all 4 are equal. I got 2 right now. How can I make it into 4? Will?
Perpendicular line through the center.
Bisect, yes. We're going to bisect our current diameter, everyone. So this is another old one. Put my compass point on one end of the diameter. Open it up. Open it up. More than half the length of your diameter. And remember, we want a decent size arc here. Go on over to the other end point. I hate when I do that. I'm just going to do it over. For some reason, in this class in particular, this is a popular move when doing this construction. I'm done. You need 2 points of intersection to line up your straight edge. Keep continuing on, please. And then go ahead, line up your straight edge. It should go right through the center as well. Now you have 4 congruent arcs. Connect them now to make your congruent chords. Right? 1, 2, 3, 4. Whoa, honors kids, not done yet. I asked for properties of a square, everyone right away, all 4 sides equal. Give me another property here. All angles are congruent. In fact, they're all 90. All right, dig deep right now. How are you going to guarantee me all those 4 angles are right angles using a circle fact from this unit? How do I know all 4 of those angles are right angles using a fact from this unit? All 4 angles are what type? Inscribed, aren't they? Where are all 4 drawn to if you follow any one of them? To the semicircle. That guarantees me, yep, right angle. Ha! Beautiful. Questions? All right, everyone can do a square. That's not bad. Great job. Let me up it now, huh? How about a hexagon inside it? I guess we got to review, right? Hexagon, how many sides? 6 sides. So that would mean I need, if I'm using the same thinking from the previous construction, I'm going to need how many arcs here? Ooh, 6 congruent arcs. Yeah. This is one where I just got to go ahead and show you because this is a new one. Put a point on your circle. Anywhere on your circle and draw on the radius from that point to the center. Anywhere you want. Here's how we're going to make 6 congruent arcs. Take your compass, measure the radius with your compass, please. Open up your compass to the length of the radius. No markings, just open up your compass to the length of the radius. Here's what I'm going to have you do. You are now going to make arcs that are the same length as your radius. Okay, you're going to make arcs. All the arcs we make right now on this circle will have the same length as our radius. So if you don't have it already, put your compass point on the circle you made. And then now we're going to make another arc on the circle. And that arc should be the same length as your radius. Yeah, it's killing me. Over here now, go to wherever you put that arc. And again, we're going around the circle until we have 6 arcs made. Because we needed 6 chords to make the hexagon. So that's how I'm going to do the hexagon. I'm going to make arcs that are the same length as my radius. And once you have 6 arcs, you can draw in your 6 chords. Starting from the original point you put on your circle. That is a vertice. And remember, definition of a regular polygon, all sides equal, all angles equal. Square, hexagon. Last one. Equilateral triangle. And unlike the last one where I showed you all the steps, I refuse to do anything for this one. I'm not doing anything. Not showing you a darn thing. It's equilateral. What's that tell you? Okay. All 3 sides have to be equal, so tell me something. Based on the way we did the last 2 constructions, what you got to know about the arcs then? You need 3 of them, and they all need to be congruent. So the problem you have to solve right now is how are you going to get 3 congruent arcs up there by just not using your straight edge and saying, hi, they look congruent. Right? If you give me 3 congruent arcs that you are sure are congruent to each other, I'm connecting them, and I got myself an equilateral triangle. How am I going to get them all? Woo. And yeah, you got to use your compass too. You can't just use your straight edge. Bridger, I don't let many people into my domain, but you see all the slides here on the left? Can you hit the previous one for me, please?
What an honor.
Okay. Thank you. Told him to do that on purpose, so you could stare at this one right here. How many congruent arcs do I need?
3. Oh, I see what he's talking about.
But there's 6 up there. Yeah, I get it. But could you use that same construction to turn it into 3 congruent arcs? There you go. I may have 4 constructions today, but it's only 3. What are you going to do to every other point here? Connect every other point, and you got yourself 3 congruent arc marks. Yes. So now you know how to do an equilateral. It's the same as the hexagon, except now I connect every other one. So we really ended up doing 3 constructions today instead of 4. So make a radius, copy it all the way around to 6 arcs, and connect every other one now. And we have an equilateral triangle. Okay, as you proceed to the 2, I know 2 might be the first time you get everyone to do it. 2 problems there. I will let you know one thing. The second problem, where you are asked to do the hexagon again, one arc will look significantly bigger than the other 5, and the reason is I think we placed the center in the wrong spot. So when you draw your radius in, it's not actually the actual radius of the circle. So if that happens, you don't need to get out of control. It's supposed to happen. And then we're not packing up early. If you get those 2 constructions done, next page, review for quiz 3, let's roll. All right, let's roll. Don't pack up early here because you get done with the first 2. All right, get those complete, get it out of the way, then go right on to review for quiz 3 on the next page. And you are done with constructions for the year.